Hello YouTubers. This video is a small demo on how to collect names of the DP slaves by the help of the Siemens instructions. Please do not forget to like the video and subscribe to the channel. Let's have a look at the hardware setup. I have an S7 1200 series CPU 1214C. This type of CPU has no integrated DP master. So in addition, communication module CM1243-5 is installed. There are 5 backend VFDs as DP slaves connected to the DP master system. The names of those DP slaves I am about to get. First of all, a DP IO master system needs to be scanned for assigned DP slaves. Instruction called LOG2GEO will be used here. This instruction will help to initialize the values of the data type GEO address and prepare its usage to scan the IO system. Let's observe the parameters of the LOG2GEO instruction. L address, hardware identifier of the module whose slot you want to find. RET val, output information of the instruction. If the error occurs, then its code will be represented here. GEO address, pointer to the slot information. GEO address contains the geographical address of a module. Let's observe GEO address structure. The structure of the GEO address is as follows. Hardware type, area, IO system, station, slot, subslot. First element is hardware type, so type of hardware will be represented here. There are 5 types of hardware that can be identified. If the type of hardware is not identified, 0 will be returned. Next element is area. This parameter is used for area ID. There can be 4 areas. IO system is a parameter where the number of IO system will be stored. 0 stands for central rack. The value of parameter station depends on the area. If area is 0, then this parameter represents the number of the rack. If area is not equal to 0, then this parameter will represent the number of the station. Parameter slot returns the number of the slot. Parameter subslot returns number of the submodule. This parameter has the value 0 if no submodule is available or can be plugged. Let's observe parameter hardware type. As I already mentioned, there can be 5 types of hardware. Value 1, IO system. It can be either PROFINET, either PROFIBUS DP IO system. Value 2, depending on area, it can be IO device or DP slave. Value 3 means rack. Value 4 means module. Value 5 means submodule. And as I already mentioned, if returned value is 0, it means that hardware type is not supported by the instruction. Let's observe the possible area IDs. Value 0, CPU. If this parameter returns value 0, then parameter station shows the number of the rack. Value 1, PROFINET IO. Value 2, PROFIBUS DP. Value 3, ACI. Observation of data type GEO address is finished. Let's dive into the programming. I have created a function block. At the very top of it, I do initialize variables. Here I do initialize the data type GEO address. Here I do assign the DP master hardware identifier to the local static variable. By the help of the for loop, here I do initialize the variables that holds the names of DP slaves. Bit error is used to notify if there was an error returned by any used instruction. Variable error level will hold the ID of the instruction that returned error. Variable error code will hold error ID, returned by the corresponding instruction. After initialization I do call instruction log2GEO, that will return the geographical address of the DP master system. In return I do save the status of the instruction. On successful execution, 0 must be returned. If the returned status value is not 0, it means that error occurred. Here I do handle the error. Bit error is set to true. Level of error is at getting ID of IoSystem. Error code is returned value of instruction log2GEO. And I do exit the function block. On successful execution of the instruction I do call another instruction, DeviceStates. This instruction is used to query specific status information of all modules in an IoSystem. In my case I do query status information of all DP slaves in a DP master system. Let's observe instruction DeviceStates. As I already mentioned, this instruction is used to query status information for all DP slaves in my DP master system. Parameter LADRESS is hardware identifier of DP master system. It is available either in the network view of the properties of the DP master system, or in the PLC tag table in the listed system constants with the data type HWTYPE. Parameter mode is used to read out status information for the entire DP master system. Parameter RETVAL returns status of instruction. Parameter state is used to buffer for status of the DP slaves. It is an array of bool, where index represents the DP slave address in the DP master system. Bit number 0 is group display. It is set to true if at least one DP slave was set to true. To display the status information of all DP slaves, the length of the array must be 128 bits. Parameter mode is used to read out one of the following status information for the entire DP master system. 1. DP slaves are configured. 2. DP slaves are faulty. 3. DP slaves are disabled. 4. DP slaves exists. 5. DP slaves for which a problem has occurred, maintenance demanded or recommended, not accessible, not available or error occurred. Before calling instruction DeviceStates I do initialize GEOADDR data type to read the states of the DP slaves. After that, I do call instruction DeviceStates with the mode, configured. So I will scan whole DP master system for configured DP slaves. On successful read of the instruction, it should return 0 as RETVAL. If the returned value of the instruction is not 0, it means that error occurred and I do handle it here by setting error bit true, error level, getting devices stated, error code, returned value of the instruction, and do exit function block. If the instruction has been executed without errors, then the names of the DP slaves can be read. For that purpose instruction getName will be used. Instruction getName reads out the name of an DP slave. Parameters of this instruction are as follows. LADRESS, hardware identifier of the DP master system. The number can be taken from the system constants or the properties of the DP master system. Station NR, PROFIBUS address of DP slave. Data, pointer to the area to which the name is written. Done, indicates successful execution of the instruction. Busy, indicates that instruction is not complete yet. Error, instruction executed with error. Len, outputs the length of the name of the DP slave. Status, displays the status of the instruction execution. It is only set for the duration of one call. The call of the instruction getName needs to be repeated until done or error has been returned. I do loop through the array with DP slaves and if configured DP slave has been found I do call instruction getName until error or done is returned. If the error occurs as the result of the instruction, then I do handle it here. I do set error bit to true. Level of the error is set to getName. Error code contains the status of the instruction getName. And I do exit the function block. If the instruction is executed without error, then I do handle its result. On the execution of the instruction, name of the DP slave is stored into the temporary variable of data type string. Data type string consists of 254 characters. Strings of the array, where the names will be saved, are set to fixed size of 10 characters. That will help me to save the memory. I delete 244 characters starting on index 10 and save it to the corresponding array at the corresponding index. Let's test the application. I will set this bit to true to start of getting the names of the configured DP slaves. All instructions were handled without errors, as there is no error returned. Let's expand the array with the names. I did get the names of the 5 configured DP slaves. Let's compare them with the hardware configuration. As you can see, all the names correspond to those configured in the hardware configuration. Result of the application is as expected. That is what I wanted to show you today. If you find this video useful, please do not forget to like it and subscribe to the channel. Thank you for watching and happy coding.